Hi friends, today we will be discussing about page replacement algorithms. So what is page replacement? Means whenever pages are full, that is page frames are full in the memory, which page has to be replaced? That is what decided by page replacement algorithm. That is, if there are no free frames, so we have to decide the victim pages from the already in the memory. So page replacement algorithms are used to decide which page to replace when there are no free frames. A good metric for calculating or setting the efficiency of page replacement algorithm is lowest page fault rate. So if we take a page replacement algorithm and its page fault rate is less, then it is an efficient replacement algorithm. And whenever we are dealing with page replacement algorithms, we will be using the concept of a reference string. So what is a reference string? A reference string is the string of page numbers representing the page references. So let us start with the basic page replacement algorithm, which is called as FIFO algorithm or first in first out algorithm. So the basic idea of first in first out algorithm is we will be replacing the page which comes first or which comes early, right? So let us see with an example. Here we have given the page references or string, or it is a reference string. So and these are reference like this, and we will be taking into consider 3 page frames, that is the 3 page frames. So at first 3 will be empty, and whenever first page is referenced, first will be entering into the memory and page fault has been occurred. Next reference string, next reference comes for page 2, and again page fault has occurred. Here again the page reference 3, page fault has occurred. Again page reference for 4, so page fault has occurred, and you can see first in first out, that is whichever has come first, it will be replaced by new coming page. So 4 is replaced here. Next reference is 1 and 2 is replaced with the same process. Next reference is 2, so 3 is replaced here. Next reference is 5, so 4 will be replaced. Next reference is 1, so already 1 is present in the page, so there is no page fault. So if you can see here, there is no page fault. Again next reference is for 2, second page, so already 2 is in our memory, so there is no page fault. Next the reference is 3, so according to first come first serve, the 1 has to be replaced, so 1 will be replaced by 3 and a page fault has been occurred. Next reference is for 4, and 4 is not present in the memory, so next page to be replaced is 2, so 4 is replaced by 2. Sorry, 2 is yes, 4 is replaced by 2, and the last reference is for 5, and 5 is already present in our memory, so there is no page fault. So you can see when you count these things, 1 2 3 4 5 6 7 8 9, there are 9 page faults out of 12 references. So this is what page fault rate is. For this reference string, the page fault rate is 9. So now whenever we are talking about for FIFO page replacement, FIFO page replacement suffers from the concept called as Belady's anomaly. So what is Belady's anomaly? Belady's anomaly states that if we increase the number of pages, the page fault rate also increases. So we may assume that if we increase the number of pages, the page fault will be decreased, but Belady's anomaly states that if we increase the number of pages, the page fault rate will be increasing. So let us see with an example how it is done. So again we are taking the same reference string which we have taken in the previous example with 3 page frames. So here we are taking 4 page frames. And we are taking the same reference string, and we will be following the same FIFO replacement algorithm. And you can see 1 page fault has occurred, 2 page fault has occurred, 3 page fault has occurred, 4 page fault has occurred. Now our page frame is full, page is full. Now again 1 comes, so 1 is already present in our memory, so no page fault. 2 is already present, so no page fault. 5, whenever 5 comes, we have to replace, so the first page to replace is 1, so 5 will be replacing 1. Next reference is for 1, so 1 is not present in our memory, so 2 is replaced by 1. Then next reference is 2, so 2 is not present in our memory, so 3 is replaced by 2. Next reference is for 3, so 3 is not in our memory, so 4 is replaced by 3. Next reference is 4, so 4 is not in our memory, so 5 will be replaced by 4. Next reference is for 5, so 5 is not in our memory, so 5 is replaced by 1. And you can see, so all we have page faults. Only for 1 and 2 there are no page faults. So if you count the number of page faults, it will be 10. So now you can see that for the same reference string with the 3 page frames, we will be getting 9 page faults, but we increase the number of pages, but we will be getting 10 page faults. And as the number of pages increased, page fault rate increased, and this is called as Belladie's anomaly. Hope you understood. Thank you.